So let's begin our discussion on estimation by defining an estimate. Occasions arise in business, social science, medicine, and science when it becomes necessary to estimate a population parameter such as a population mean. Let's remember the definition of a parameter was a number that describes the characteristic of a population. So the population mean is a population parameter. Most of the time the population is too large and it would be impossible or impractical to obtain the entire population data. For example, an entire inventory of products. Or if we go back to the very first lecture on our discussion on a census is only conducted every 10 years because it is very timely and costly to get done. So in such cases, instead of using a population, we select random samples from the population and we use sample data, and that sample data is used to estimate the population parameter. So we can use a sample mean to estimate a population mean. The process of using sample data to make an inference or a conclusion about a population parameter is statistical inference. So you may remember from the beginning of the course our discussion on the branch of statistics called inferential statistics, and that branch was all about using samples to come to conclusions about populations. So one major area of statistical inference is estimation. That's what we're going to do now. So the process of taking a sample from a population, finding that sample mean, and then using that sample mean to estimate the population mean is basically what we're going to do in this chapter. Let's look at, this is taken from an online website, Gallup.com. Gallup is a very, very well-known organization that does polling, and they poll the approval rating of presidents, and you can find this data all the way back to the 1950s. This is Obama's job approval rating, and you can see that each result is based on a 3-day rolling average. Now, this approval rating was taken in October of 2012. And at the time, 49% of people in the survey or in the sample, that's the light green, approve of the job the president is doing, and 44% of people in the sample disapprove of the job the president is doing. And you can read a little bit more information here at the bottom. Gallup, that's the organization, tracks the daily percentage of Americans who approve or disapprove of the job Barack Obama is doing as president. Daily results are based on telephone interviews with approximately 1,500 national adults. That's your sample size. The margin of error is plus or minus 3 percentage points. And we're going to discuss the meaning of a margin of error in a second. Now I want to show you, if ever you want to look up the job approval rating at any specific point in time, say you want to find the current job approval rating for the president, I did a Google search for Gallup President Approval Rating, and you'll be brought to the Gallup.com website. Here's the URL, Gallup.com poll, and there's a code, and you see the name of the site. And what you see here is the job approval rating today. And if you hover your mouse above the data at any point in time, you see the approval ratings and disapproval ratings change as you progress through the graph. Now today, it's a 41% approval rating and a 51% disapproval rating, and this is conducted all the time, so you can always, depending on the election season or current events that are going on, you can go and see how the president's approval rating changes. And again, the poll doesn't change. It's still 1,500 national adults with a margin of error or plus or minus 3 percentage points. So you can find lots of other things at Gallup.com. They're an organization that does polling, and there's political polling, and there's economic polling, and you see these tabs at the top, well-being and world. There's lots of information that you can look up here and find interesting or possibly use for your purposes. So going back to, this is an older slide, an older approval rating, but the concept still is the same. What we're going to do is examine that margin of error. So the margin of error is there because this is a sample and not a population. So we don't know that the whole population has a 49% approval rating or a 44% approval rating. We don't know that. We have an estimate of it. And the margin of error is there because the percentage of the sample shown may not be exactly the same as that of the population. Population may not be 49% or 44%, so plus or minus 3 points provides us with an interval or a range of possible values. So knowing that a margin of error gives us an interval, what is the interval of the percentage of people who approve of how President Obama is doing as of this date, which was October 2012? Well, if we take the 49% and we subtract 3 percentage points, and we take 49 and we add 3 percentage points, it gives us a range of values that range from 46, 49 minus 3 is 46, to 49 plus 3, which is 52. That's 46 to 52%. Now that interval estimate is an estimate for the population, okay? Because we know our sample said 49, and we could estimate that the population would have a value somewhere between 46 and 52. Now coming up with that margin of error plus or minus 3 points isn't just random. There is some mathematics with that, and we are going to talk about that in this lecture. So in this chapter we're going to use sample data to make inferences about a population. So we won't have the population data, we'll only have the sample data, and we'll calculate a sample mean and we'll make a conclusion about a population mean. And that is the whole purpose of inferential statistics. So we're going to use sample data to make estimates about population parameters. So remember the definition of a characteristic or a number that describes the characteristic of a sample was called a statistic. So we're basically using statistics to make estimates about parameters. So 49% in our presidential approval rating is a sample statistic. And in inferential statistics, we're going to use that sample statistic of 49% to estimate the percentage of the entire U.S. population who approves of the president. So let's look at some definitions. Estimation is a statistical procedure which uses sample information to estimate the value of a population parameter, such as a population mean. So in our context, that is what the meaning of estimation is. A point estimate is a single number. A sample estimate of a population parameter, such as a population mean. So if we are estimating the population mean with a number, the point estimate would be the sample mean. Okay, it's a single number that's used to estimate a population parameter. So for example, if we're estimating the population mean, the single number that we're using for that estimate would be a sample mean. So the sample mean is a point estimate used to estimate a population mean. Now, why do we need confidence intervals? Well, if we express the percentage from the presidential approval rating as a decimal, 0.49, That is only an estimate for the percentage of the population who favor the president, but it's no indication of how good the estimate is, and that is why we were provided with a margin of error. The flaw in the estimate leads to the development of what we call confidence intervals. Confidence interval is a range of numbers, and they consist of a range or interval of values instead of a single value. So instead of a single point estimate, 0.49, we are provided with a range, a confidence interval, an interval of values. And every confidence interval that we create is going to be associated with a confidence level. And the confidence levels are going to be 95%, which we'd express as a 0.95 confidence level. 90% confidence level will be a 0.90, and 99% confidence level would be 0.99. And that confidence level is a degree of certainty, meaning how certain we are of the estimate that we arrive at. Each confidence level provides a different range of values, so instead of just 0.49, we have 0.46 to 0.52. A different range of values instead of a single value as an estimate of the population parameter. The sample statistic, the 0.49 for example, is the center of the confidence interval. So this is just a brief overview of what a confidence interval is, and when we create one, it's going to seem more obvious what these numbers mean. So a 95% confidence interval, for example, produces a range of values around a sample statistic. So let's suppose that we've gone through the mathematics and we produced a confidence interval to estimate a student's GPA at Nassau Community College. We created a 95% confidence interval and it came out to be 2.43 to 2.83. An estimate for the mean student GPA at Nassau Community College. So using this interval, what we are trying to do is estimate what the whole population mean GPA of Nassau Community College students would be. Okay, because this interval is used to estimate the whole population. So when we come to our conclusion, we can state that the 95% confidence interval means that we are 95% confident that the interval from 2.43 to 2.83 contains the true population mean mu. Again, we're trying to estimate the population mean GPA. We don't know it exactly, so we produce this range of values, 2.43 to 2.83, a range of values to come to an estimate that what the true population mean could be. Another way of stating that same thing would be to say that there's a 95% chance, because this is all based in probability, that the interval from 2.43 to 2.83 contains the true population mean mu. Okay, so in all of our problems, we are attempting to estimate mu. We're attempting to estimate the true population mean. And we're going to do this by coming up with an interval of values based on a sample mean. Okay, so there is a possibility that the true mean is not in the range from 2.43 to 2.83, but it's a small 5% possibility. Okay, so we're 95% sure that it is within the range from 2.43 to 2.83, and there's a 5% possibility that it's not within that range. So if you increase the confidence level from 95 to 99, you're increasing the chance that the true population mean lies within the interval that you find. So if you increase the confidence level, you increase the probability. If you decrease the confidence level, you decrease the probability. So in this chapter, we are going to be constructing 90, 95, and 99% confidence intervals for sample means. So we're going to be starting with a sample mean x bar, and we're going to be constructing a range of values around x bar, and that range of values is used to estimate the population mean mu. And we're going to figure out what the margin of error is for our constructed confidence interval. So before, I was just assuming that we had already done the mathematics to come up with the confidence interval 2.43 to 2.83. Okay, but what we're going to do is learn exactly how those numbers are arrived. It's all based on the sampling distribution of the mean. Okay, remember chapter 8, the sampling distribution of the mean is basically the foundation for confidence intervals. If we're estimating a population mean, we use the sampling distribution of the mean. And remember that that distribution is approximately normally shaped if we are sampling from a population that's normal or if our sample size is greater than 30. And there's one more condition. If we're sampling from a population mean, but we don't know the population standard deviation, we're going to learn a new distribution. It's called the t-distribution. And it's used in cases when we don't know the population standard deviation. And you're going to see that we'll be using the sample standard deviation in cases when we don't know the population standard deviation.